Extending circuits from existing panels to a generator panel can introduce voltage drop, especially for circuits with high amperage loads. This can lead to reduced appliance performance or even damage. The receptacles in the existing panels may not be compatible with the new generator panel. This can create a safety hazard if the generator panel is not properly grounded and receptacles are not of the correct type. Extending circuits may require additional conduit and wiring, which can be costly and time-consuming to install. If the owner turns on too many circuits simultaneously, the generator may become overloaded. This can damage the generator and cause it to fail. Overloading the generator can also pose a fire risk. If the generator overheats, it could start a fire. If the owner accidentally turns on a circuit that is not compatible with the generator, it could create a dangerous electrical shock hazard. To address these concerns, it is recommended firstly to use a transfer switch with a built-in load management system. These systems monitor the generator's load and automatically shut non-essential circuits to prevent overloading. Secondly, install a generator panel with individual circuit breakers and meters. This allows the owner to see the load on each circuit and make informed decisions about which circuits to turn on. Thirdly, properly size the generator. Ensure that the generator is capable of handling the total load of the essential circuits that will be powered during an outage. Explain the importance of not overloading the generator and provide clear instructions on how to operate the generator and transfer switch safely. Voltage drop is a critical consideration when extending circuits for generator use. It's the reduction in electrical potential along a conductor. An excessive voltage drop can negatively impact the performance and lifespan of appliances and equipment. Several factors contribute to voltage drop, including the length of the wire, the gauge of the wire meaning its thickness, and the amount of current flowing through the wire measured in amps. Longer wires exhibit greater voltage drop because there's more resistance over the extended distance. Thinner wires have higher resistance compared to thicker wires, leading to increased voltage drop. Higher current also exacerbates voltage drop because more electrons are forced through the conductor. To mitigate voltage drop, firstly, minimize the length of circuit extensions whenever possible to reduce resistance. Secondly, use appropriately sized conductors based on the anticipated load and the distance of the run. Consult the National Electrical Code, specifically Table 310.15, B16, for proper ampacity ratings and wire sizes. Thirdly, consider using low voltage drop extension cords for temporary connections. Regularly inspect wiring and connections for any signs of corrosion or damage, which can increase resistance and voltage drop. Receptacle compatibility is another crucial aspect to consider when integrating a generator into a home's electrical system. Ensuring that the receptacles in the existing panels are compatible with the generator panel is essential for safe and reliable operation. Compatibility issues can arise from differences in grounding configurations, voltage levels, and plug types. Generators typically have a different grounding system compared to standard utility power, and mismatches can lead to ground loops, electrical noise, and even equipment damage. Voltage differences between the generator and the existing electrical system can also cause problems, as appliances are designed to operate within specific voltage ranges. Using incompatible plug types can create a safety hazard, as it may lead to improper connections and potential electrical shock. To ensure receptacle compatibility, firstly, verify that the grounding systems of the generator and the existing electrical system are properly bonded and grounded according to local electrical codes and the National Electrical Code, specifically Article 250. Secondly, use a transfer switch that is specifically designed to switch both the hot and neutral conductors to prevent ground loops. Thirdly, use receptacles that match the voltage and amperage ratings of the circuits being connected. Fourthly, ensure that all connections are secure and properly insulated to prevent electrical shock. Consult a qualified electrician to assess the existing electrical system and make any necessary modifications to ensure compatibility with the generator. Conduit and wiring limitations can present challenges when extending circuits from existing panels to a generator panel. Adding new circuits or extending existing ones may require additional conduit and wiring to safely accommodate the increased load. Conduit provides physical protection for electrical wiring, safeguarding it from damage and environmental factors. Wiring must be of adequate size to handle the anticipated current flow, and it must be installed in accordance with the National Electrical Code. Limitations in conduit capacity, wiring size, or available space can restrict the ability to extend circuits. Firstly, assess the existing conduit and wiring to determine its capacity and condition. Overfilled conduits can lead to overheating and insulation damage, increasing the risk of electrical fires. Secondly, use appropriately sized conductors based on the anticipated load and the length of the circuit run. Consult the National Electrical Code Table 310.15, B16 for proper ampacity ratings. Thirdly, if necessary, install additional conduit and wiring to accommodate the extended circuits. Ensure that the new conduit is properly sized and installed according to local codes. Fourthly, consider using flexible metal conduit for ease of installation in tight spaces. Carefully plan the routing of new wiring to minimize interference with existing systems and to ensure accessibility for future maintenance. Generator overload is a significant concern when allowing homeowners to select which circuits will be powered by the generator. Overloading a generator can lead to serious consequences, including damage to the generator itself, fire hazards, and potential electrical shock. Generators are designed to provide a specific amount of power, and exceeding this limit can cause the generator to overheat and fail. Overloading can also create excessive voltage drop, which can damage appliances and equipment connected to the generator. Firstly, educate the homeowner about the importance of not overloading the generator and provide clear instructions on how to calculate the total load. Secondly, install a generator panel with individual circuit breakers and meters to allow the homeowner to monitor the load on each circuit. Thirdly, use a transfer switch with a built-in load management system to automatically shed non-essential circuits when the generator is nearing its capacity. Fourthly, create a load management plan that prioritizes essential circuits and minimizes the simultaneous use of high-power appliances. Regularly inspect the generator for signs of overheating or damage and have it serviced by a qualified technician as needed. Fire risk is a critical safety concern associated with generator operation, particularly when the generator is overloaded or improperly maintained. Generators produce heat as a byproduct of combustion, and excessive heat can ignite flammable materials nearby. Overloading the generator can cause it to overheat, increasing the risk of fire. Improperly maintained generators may develop fuel leaks or electrical faults, further exacerbating the fire hazard. Firstly, position the generator in a well-ventilated area away from flammable materials such as gasoline, propane, and dry vegetation. Secondly, regularly inspect the generator for fuel leaks, oil spills, and loose connections. Repair any issues promptly to prevent potential fire hazards. Thirdly, install a carbon monoxide detector in the home to alert occupants to the presence of dangerous levels of carbon monoxide, which is a byproduct of generator combustion. Fourthly, ensure that the generator is equipped with a spark arrestor to prevent sparks from igniting nearby flammable materials. Keep a fire extinguisher readily available near the generator and know how to use it properly. Electrical shock hazard is a serious risk associated with generator operation, particularly when the generator is improperly grounded or when circuits are not compatible. Electrical shock can occur when a person comes into contact with an energized conductor or a conductive object that is not properly grounded. Generators must be properly grounded to provide a safe path for electrical current in the event of a fault. Incompatible circuits can create a potential difference between different parts of the electrical system, increasing the risk of electrical shock. Firstly, ensure that the generator is properly grounded according to local electrical codes and the National Electrical Code. Secondly, use a transfer switch that is specifically designed to switch both the hot and neutral conductors to prevent ground loops and potential differences. Thirdly, use ground fault circuit interrupters, or GFCIs, on circuits that are likely to be exposed to moisture, such as at door outlets and bathroom circuits. Fourthly, never operate the generator in wet conditions, as water can conduct electricity and increase the risk of electrical shock. Regularly inspect cords and connections for any signs of damage or wear and replace them as needed. A transfer switch with a built-in load management system is a valuable tool for preventing generator overload and ensuring reliable power during outages. These systems monitor the generator's load and automatically shed non-essential circuit when the generator is nearing its capacity. Load management systems typically use sensors to measure the current flowing through each circuit and a controller to prioritize circuits based on their importance. When the generator reaches a predetermined load threshold, the controller automatically disconnects non-essential circuits such as air conditioners, water heaters, and electric dryers to prevent overload. Once the load drops below the threshold, the controller automatically restores power to the non-essential circuits. Firstly, select a transfer switch with a load management system that is compatible with the generator and the existing electrical system. Secondly, configure the load management system to prioritize essential circuits, such as lighting, refrigerators, and medical equipment. Thirdly, regularly test the load management system to ensure that it is functioning properly. Fourthly, educate the homeowner about how the load management system works and how to manually override it if necessary. Consider using a smart load management system that can be controlled remotely via a smartphone or tablet. A generator panel with individual circuit breakers and meters provides homeowners with greater control and visibility over the power distribution during outages. Individual circuit breakers allow homeowners to selectively turn on or off circuits based on their needs and the generator's capacity. Meters display the current draw of each circuit, allowing homeowners to monitor the load and avoid overloading the generator. This arrangement empowers homeowners to make informed decisions about which circuits to power, optimizing the use of the generator's capacity and minimizing the risk of overload. Firstly, install a generator panel that is sized appropriately for the number of circuits that will be powered by the generator. Secondly, label each circuit breaker clearly to indicate which appliances or devices it controls. Thirdly, provide the homeowner with a load calculation worksheet to help them estimate the total load of the circuits they plan to power. Fourthly, educate the homeowner about how to read the meters and interpret the load information. Consider using a smart generator panel that can be monitored remotely via a smartphone or tablet. Properly sizing the generator is essential for ensuring that it can handle the total load of the essential circuits that will be powered during an outage. An undersized generator may not be able to provide enough power to keep essential appliances running, while an oversized generator may be inefficient and costly to operate. The generator's capacity should be determined based on the total wattage of the essential circuits, taking into account any surge loads from appliances such as refrigerators and air conditioners. Firstly, create a list of all the essential circuits that will be powered by the generator, including the wattage of each appliance or device. Secondly, calculate the total wattage of all the essential circuits, adding any surge loads from appliances with motors. Thirdly, select a generator with a capacity that is at least 20% greater than the total calculated wattage to account for future expansion and unforeseen loads. Fourthly, consult with a qualified electrician to verify that the generator is properly sized for the specific application. Consider using a generator sizing calculator to assist with the load calculation process. Educating the homeowner is crucial for ensuring that they understand the importance of not overloading the generator and how to operate the generator and transfer switch safely. Homeowners need to be aware of the potential risks associated with generator operation, including fire hazards, electrical shock, and carbon monoxide poisoning. They also need to know how to calculate the total load of the circuits they plan to power and how to prioritize essential circuits. Proper operation of the transfer switch is essential for preventing backfeed, which can energize utility lines and create a dangerous situation for utility workers. Firstly, provide the homeowner with a comprehensive user manual that covers all aspects of generator operation and safety. Secondly, explain the importance of not overloading the generator and provide clear instructions on how to calculate the total load. Thirdly, demonstrate how to operate the transfer switch properly, emphasizing the importance of switching off the main breaker before switching on the generator. Fourthly, advise the homeowner to install carbon monoxide detectors in the home and to test them regularly. Regularly review safety procedures with the homeowner and address any questions or concerns they may have.